In these first few slides, we have started to use terms such as system, surroundings, process, closed, isolated, and so on. Terms that are an integral part to the thermodynamic language. So we need to make sure we have a clear understanding of what these terms mean. As we have alluded to earlier, a large part of learning a new field consists in learning its jargon or language. For better or for worse, you will be judged by your mentors and your peers as being knowledgeable or being ignorant in a field depending on how well you know the language of that field. This applies to thermodynamics as it applies to all other fields of study. So what do we mean by system and surroundings? The system is the part of our universe we are interested in studying. It can be, for example, as simple as a sample of gas in a cylinder piston assembly, or as complicated as a reactive mixture, a cell, an organ, and so on. The surroundings should be the part of the universe outside the system that can exchange energy and/or matter with the system. Obviously, when doing calculations, we would like to include every part of the universe that interacts with the system. Often, for practical reasons, and to keep calculations manageable, we choose the parts of the universe that interact the most and the most strongly with the system, and ignore these that interact negligibly or weakly with the system. A good example where such considerations come into play is in the area of weather forecasting. We will often consider the surroundings to exhibit constant pressure. We would say that the pressure outside the system, or the external pressure, is constant. In contrast, we could also consider the volume of the surroundings to be constant. This is not an assumption we will find very useful in most of our calculations. Another common assumption made during thermodynamic calculations is for the temperature of the surroundings to be constant. This can be achieved experimentally by keeping the system in an oven or in a refrigerator at constant temperature. Alternatively, you could consider immersing your system in an extremely large water bath kept at constant temperature. Under such condition, you can envision that you can even run at constant temperature a chemical reaction that releases a lot of heat, since the transfer of heat from the reactive system into the extremely large water bath would not lead to a change in the temperature of the bath. Obviously, if the water bath was too small, you would see a change in its temperature, and the reaction would not be run at constant temperature. So it will be important to pay attention to the nature of the surroundings when we solve thermodynamic problems, as this will define the assumptions we can make during our calculations.